All right, 3 and 4 for the inequalities. Let's get to it. Number 3 is already set up nicely. We can graph it if you wish. Find out when it's less than 0, and that'll be whenever the graph is below the x-axis. Very similar to number 1 over here. We wanted it above the x-axis on that one. All right, I'm just going to graph it real quick. We have a horizontal translation of 2 to the left, resulting in vertical asymptote being over here at the line x equal to -2. Let's see. There's no vertical translation, so in that case, the horizontal asymptote will stay the x-axis at the line y equal to 0. So there are no x-intercepts. So our graph, there's not much more that we really have to do. Let's do our y-intercept real quick. Plug in 0 plus 2, you get 3/2. 1, 2. Okay. If you were to graph it, the left side will look like that. If you were to graph the right side, y equal to 0, well, it's the x-axis. This one's pretty straightforward. When is it less than 0? This branch right here. So that occurs, so your solution is all x's that are strictly less than -2. If you did the number line based off of the key value of -2 and tested numbers before and after, I already plugged in 0. So you plug in 0, we have positive over here. Let's plug in -3, you would get, plus -1, -3. So you would get negative over here. So there you go. Our solution is all the x's strictly less than -2. That one's done. Not much work was needed. All right. Number 4 is going to require all the steps we did on number 2. So let me make some space here. Step 1, set it to 0. So minus x on both sides. Step 2, rewrite it as one fraction. So x over 1. So my common denominator will be x plus 5, which I have to introduce. There it is. I'm going to run out of space quite quickly. So x plus 5 is my common denominator. Let's go ahead and start combining like terms. So over here, we're going to get x squared plus 5x when you distribute that x. We have a minus sign. That's going to apply to both of them. So minus x squared minus 5x. This is all greater than or equal to 0. Is there another one that had that equality? No, okay. We'll deal with that in a second. Okay, let's go ahead and find our key values. So when is the bottom equal to 0? So the bottom is equal to 0. Let me figure this out. That'll give us our vertical asymptote or hole in the graph if we were to cancel. But when x is -5, the bottom is equal to 0. So on our number line, and you know what, let's move this over here. We'll get our number line going here. -5 is one key value. That's when the bottom is 0. Let's set the numerator equal to 0 and solve that as well. So my numerator, -x squared minus 5x minus 4. We need to find out when that's 0. I'm going to factor out -1. It's going to make things a little easier to work with. All right, this one's going to factor out nicely. X plus 4, x plus 1. Okay, so my numerator is equal to 0 when you plug in -4 and -1. Denominator is equal to 0 at -5. All right, so at those values, this left side of my inequality is not positive, not negative. It's either undefined, where you have a vertical asymptote, a hole in some cases. With this case, it's a vertical asymptote, or it's an x-intercept, where the y-coordinate is 0. So we need to test out values in between those. So let's have at it. Let's plug in 0. All right, we plug in 0, so 0 there, 0 there, 0 there, get -4/5. We get a negative value there. But put that, let me clear out these zeros. It's negative for all x's greater than -1. All right, let's plug in -2 and see what happens. So -2, -2, -2. We're going to have a positive value on the bottom, +3 there. Up top, let's do some calculating. -4 minus +4 plus 10. Looks like positive up top. So positive over positive is positive. Yeah, I'm sorry, let me clear some of this out before I put positive there. All right, between -5 and -4. So we need to plug in a value in between there. So we have to pick, I would go with -4.5. And then over here, let's plug in -6. Plug it into the left side and determine what the output will be. All right, I plugged in -6 and I got a positive here. I plugged in -4.5, I got a negative value. We want the interval such that it's greater than or equal to 0. So I need positive intervals. So I'm looking at over here. At -5, it's undefined. We're not including that. And I'm looking in here. It can be equal to 0, so we can include the endpoints. So my final solution to this one will be -infinity. All the way to -5, do not include it. Parentheses, -5 cannot be plugged in right there. Not defined there, it's not equal to 0. Union with, and here we are going to include -4. You plug in -4, it is exactly 0. To -1. Also included, it is exactly 0 there, and it can be equal to 0. So that is our solution set. You can do inequalities as well, put x in between with the proper inequalities. So there is 3 and 4. That's your solution right there.